Today I'm going to be talking to you about Kubernetes architecture. As you probably know, unless you picked the just random breakout session because you didn't know which one to pick, but hopefully you chose me on purpose. But first, a little bit about me. So I'm a senior systems engineer at Ticketline. I do a bit of mix of everything. I'm not a Kubernetes specialist, but I like Kubernetes a lot. And I did do a lot of Kubernetes work at my previous employer. Unfortunately, me and Kubernetes are no longer working together, but that's neither of our fault, particularly. And I'm really into vintage computers and trying to give back through speaking and volunteering and a bit of traveling and gardening. I want to start with a slide which represents what Kubernetes was to me when I first met it, because I'd hardly done anything with Docker, and it just seemed like magic to be able to put some YAML in and get some applications out. And all I was doing was messing around, doing trial and error, trying to figure out why this worked and why this didn't work, and taking absolutely no trouble at all to understand the terminologies around Kubernetes or anything about it at all. So I was incredibly lazy. And it worked until everything fell down. Now, it wasn't my fault, and I actually ended up fixing it, but I learned a lot from the experience. Mainly, don't use complicated tools without trying to understand them. And I've got a few little things. Firstly, I'm going to talk about the mental model around Kubernetes a little bit. Then I'm going to talk a little bit about the theory of the architecture, and then a little bit about what actually happens when you put that YAML inside that magical black box. So, there are many Kubernetes, many little differences, many different terminologies, but there's one standard, and that's what makes a Kubernetes. Whether you're using vanilla Kubernetes or highly modified cloud provider Kubernetes or a tiny little Kubernetes assigned for the edge like K3S. Kubernetes is a simple idea. It's just a way of managing containers. Or as someone very aptly put it in a random AWS Summit talk, which I've now quoted and put in this presentation, just distributed remote command execution. But it's a complex system with its whole own language of different things. And I think this is a big part of what makes it so hard to understand, is that it's a massive jump from this world where everything is just computers with extra steps. And that analogy doesn't really work very well on Kubernetes, because even with the way simplest cluster, now this could technically be simple. I could merge together the worker and the control plane, but for diagrammatical simplicity, I've sacrificed architectural simplicity. So this analogy just doesn't work. That's because it's a distributed compute system, and needs a different analogy. And to my mind, Kubernetes is a lot like a business. In fact, specifically, it's a lot like my previous employer, but we won't go there. So you need the infrastructure, so you need the factory, you need the office, and you need the managers. You need the people to tell people what to do, to think about what's being done and why it's being done. And you need the worker nodes, the minimum wage workers to work in the factory, on the call center phones, or in the warehouse. And you need some way for all these people to communicate. In this case, I'm just talking about container networking, which don't think too much about that analogy, please. So, firstly, infrastructure. So for me, infrastructure has got four components. You need the nodes and the actual physical stuff to make it all work. If you're on a cloud provider, then you don't really need to think so much about this. You just need to kind of pick out how much capacity you need and what instance types provide it. But it's important to understand what's actually going on in those instance types and what the work they're doing behind the scenes is. So each one of these nodes need two fundamental things. It needs a container one time to actually do the hard work and to be spoken to by Kubernetes to run containers. And it needs the kubelet service, which runs as a system D or other service on the system to translate the pod specs into containers, as well as answer queries about the pods that are on the node and other such important things. And of course, you'll need a deployment tool to bring it all together because Kubernetes is far too complex to deploy by hand. The control plane is the critical management layer. So it thinks about everything the cluster needs to do, makes decisions. It's assigned to run across multiple nodes. The more the better within reason. And to remember what exactly is going on in the cluster. And it's also way microservice is orientated, which I absolutely love because it's so cool that Kubernetes is run by containers, for containers. And everything except from kubelet and the container runtime are containerized microservices. There's some are microservice monoliths, but we'll get into that in a bit. Well, and a bit is right now. So the first component is the control manager. So to me, it's a bit like the HR management role rolled into one. It monitors and it manages, and it generally runs around being bossy. So it's kind of like a monolith. It's got many different processes that are just rolled into one. And one's on the control plane in the container. It checks in on nodes, reports to the cluster if they aren't functional or not responding, and creating default service accounts and namespaces. It does lots and lots of other things as well. There's another variant of the controller manager, which is specifically for plugging into cloud instances. It's an interface layer so that cloud providers can adopt Kubernetes without losing the interoperability, so that you can run the same pods, same services across AWS, Azure, and all the other cloud providers. It's basically just the same idea but different jobs. And so it's thinking about things that are at a deeper layer from the controller manager, like asking the cloud if the nodes that have disappeared have actually been deleted on purpose. And the API server is the layer which you speak to. When you use kubectl, you're speaking to the API server. And it's also used from inside the cluster to find out information about the cluster. It's also a microservice. It's just a fancy HTTPS server, and it's a kind of it's the absolute critical hub in the hub and spoke network model of Kubernetes. And then ECD. So ECD is kind of a bit different from all the other things because those are all part of the Kubernetes project, whereas ECD is a separate open source project that just gets used by Kubernetes. It runs in a distributed fashion normally across the master nodes, but it could run in a separate cluster and probably will in more highly available environments. And it's not technically tied to Kubernetes in any way. Its job is just to store all the data for the cluster. So, for instance, it will store what pods are deployed, what deployments are deployed, information about what nodes are in the cluster, what the IP addresses are, and stuff like that. So that the cluster can then restore from its stage, whether to be a power cut or etc. Finally, this scheduler. So it's a bit like project management. It just takes newly created pods, gives them some nodes to run, and it kind of thinks about which pods should be run on which node based on many different factors, such as resource availability, affinity, and etc. We work in managed nodes. The minimum wage workers of the Kubernetes world, they're disposable. They don't do any thinking. They aren't They aren't important in the same as individuals, but they are important as a group because the cluster wouldn't be able to do any useful work without them. And one of their key functions as well as running the actual workloads is to run kube proxy, which directs the traffic from load balance IPs to the specific pods that's serving the services. Finally, container networking. So the fundamental idea of the container network interface is to give every pod an IP address and then to provide networking services between them and the outside world as well. There's a standard called the container network interface. I've titled that, which specifies exactly what this should do and how it should talk to Kubernetes. But there are many different ways to implement this standard, and there are many different tiny little differences between them. You have to choose which one, and you have to install it, which is very often a fruit gun when creating a real Kubernetes cluster. Finally, DNS. So DNS isn't strictly necessary, but most implementations of Kubernetes will have it because it means that you can resolve a service name to a service IP address. And there are many different ways of doing it. Kubeadmin does it as two core DNS nodes on the clusters, but cloud providers kind of do their own thing. And obviously it proxies DNS requests to external servers. And there's lots of things I've left out here. There's node communications, there's authentication, what you actually need to do to get this all to production, and probably more that I haven't even thought of. But this is kind of the gist of it. And now to bring you on a little bit to talking a little bit about something more practical. So this is a fairly simple YAML file to create 3 replicas of Nginx container. It requires a deployment, a replica set to keep those, to keep the 3 pods as 3 pods, not 2 pods or 1 pod or 4 pods. And it says absolutely nothing about data or how to make it externally accessible. And this is the gist of what actually happens when you try to deploy it. So it starts with you using your tool to deploy it, wherever that is, whether it's kubectl or that's a GUI tool or something else. That tool sends a HTTP request to the API server, which will be authenticated. Exactly how that works obviously depends on how you've set things up. And the API server will create the objects in the ECD cluster, so here we'd want a deployment object, a replica set, and 3 pod objects. Kubescheduler will find their new pods without a node assigned, and then it will make decisions about which worker should have those pods. And then kubelet and the target nodes will receive instructions and pod specs to run those pods. And then it will hand off to the container, one tiny interface to actually do the work of running the containers. And once that's done, the controller managers will monitor and find out if those nodes have gone away. And if so, we assign their workload, or if something happens to pods, then new pods will be created to keep the replica set 3 containers going. And obviously, as well as this, you would normally have a service, or you'd have volumes so that the Nginx data was persisted. And these can have their own separate processes, but the first 2 things always happen no matter what you are deploying. And that's me. That was pretty fast, as usual, but yeah, plenty of time for questions and discussion, if you've got any.